Okay, welcome back. We're on page 113 of the indices chapter in Active Maths 3. So just get straight into exercises 4.1. So the first question here is to write the following without using a calculator to calculate these values. So I'm just going to get the layout of the questions in order to kind of keep organized. So we'll say that 5 squared is 25, minus 6 all to be cubed is equal to, well, a negative cubed will be negative, and then 6 cubed is 216. Minus 4 to be squared equals 16. And again, did they say, yeah, evaluate without a calculator. 2 cubed equals 8. Minus 2 all to the 4 is the same as 2 to the 4, which is 16. Anything to the 0 is 1 by definition. Any non-zero to the 0 is 1 by definition. Minus 5 squared is the same as 5 squared. Anything to the power of 1 is itself. And that's the first question done. Okay. Now moving down to question 2, we have, assuming that a to the power of n equals b, find the values of a, b, and n in each of the following. Okay, let's try and figure out what they're on about here. A is the first odd prime number, that's 3, and n is the number of faces on a die, that is 6. And then 3 to the 6 is our friend 729. As we discussed in class today, that's our scoop. You can use the calculator if you need to do, but that's 729. Now, that's part 1. Part 2. A is the only even prime number. That's 2. And b is the number of squares on a chessboard. Pretty sure that's 64. Number of squares on a chessboard. And now we're calculating that. I have to go to the internet to just double check. Now 2 to the 64, I have no idea what that is, and it's going to be, it's not going to come up on the calculator as anything bar, it's going to come up like with 1 to the 8, 4 by 10 to the 19, so that's only approximation, that's not the real answer. That's an annoying question because we don't have the exact answer, but you could say 1.85 by 10 to the 19 as an approximation. You can also get very frustrated as you're trying to do these, and so I'm not very comfortable with that question. B is the number of meters in a kilometer. It's 1,000, and that's over here at B. And n is the number of divisors of 4. Well, 1, 4, and 2 go into 4, so the answer is 3 divisors of 4. So B is the number of kilometers, that's B out here, 1,000. And n is the number of divisors of 4, so we have power of 3. So the question is, what to the power of 3 gives 1,000? Well, 10 to the power of 3 gives 1,000. Okay, and there was a bit of cryptic thinking in some of these questions, or working backwards certainly, and using common sense rather than algebra. Okay, going to question 3 in the very first section of exercises in your book, we have to say that in the table below match each number in column A with one number in column B. Okay, how can I show you this? How do we do this? Now let's see. Okay, so 3 to the 4, that's 81. So I'm going to have to write these out. 3 to the 4, minus 2 all to the 8, minus 6 all to the 8, minus 4 to the 4, that's negative, minus 6 to the 8. There's a difference between what I said there, minus 6 to the 8 as opposed to minus 6 all to the 8. Here we go, minus 4 all to the 4, minus 3 cubed, minus 5 all cubed. So look at how I use the word all, and minus 2 taken all to the power of 4. Okay, and we have minus 4 to the 4, minus 6 to the 8, minus 125, 27, 6 to the 8, 16, 81, 4 to the 4, and 256, which is 2 to the 8 by the way. Which is, that connects with that. And now you're asking me today in class at one stage, should we know the various powers? And I was saying it's really good to recognize them. And there's an example of a type of exercise where knowing the powers of 2 makes that question a bit quicker. Okay, minus 6 to the 8 and 6 to the 8 are the same thing. Minus times, well, the minus in here doesn't really matter, so that connects up there. Minus 6 to the 8 and these two are the same. Minus 4 all to the 4 is the same as 4 to the 4. Minus, now minus 3 cubed will be 81, but then there's another minus here which will get us into 8 plus 81. This is negative 125. Minus 2 to the 4 is 16. Leaving 3 to the 4 loose. Where the heck does 3 to the 4 go? Well, 3 to the 4, it's not 27. It should be 3 to the 4, 27. That's a mistake. That should be 3 to the 3. So I don't think they ever get paired. Okay. Now, pushing on down to question 4. We're just doing powers of 2. 2 squared, 2 cubed, 2 to the 4, and my biggest problem here is just fitting it into the page. 2 to the 5, 2 to the 6, and 2 to the 7. Well, I know I've learned this off very, very well. You get 2, 4, 8, 16, 32, 64, and 128. Okay, and over time you're going to realize you really are better off knowing them, and there's some silly ways to know them, like 2 to the 5. The 3 and the 2 add to 5. It doesn't really mean anything mathematically, but the 3 and the 2 do add to 5, and after a while you just get the hang of that. 2 to the 6 starts with 6, just like 2 to the 10 equals 1024. Okay, you get to that later on. 2 to the 7, 8 take away 1 is 7. Just got to learn them off essentially. Now powers of 3 is next. 3 squared, 3 cubed, and this is where we're going to bring in our calculator to do these, to do a string of them, because you've got a powerful calculator in your hand here. So I'm going to turn it into table mode, okay, and I'm going to leave the x as the variable, so 3 will be in my formula, okay, and I bring up to the power of, and then I turn on my red x. Okay, I'll start it at 1 and I'll end it with 6. And that gives me step it of 1, and that gives me all those numbers here. So I can start writing them out as they appear. 3, then 9, then 27, then 81, then 243. I call that day 3, because day 3, 2 and 24 is a day, day 3, silly way of remembering it. And then there's our friend 729, which are going to appear over and over and over again. Okay. Now I can do the same with 4s, and indeed I can hit AC and turn that 3 into a 4. Okay, and then it's starting, ending with the same, everything else stays the same, and you basically get this series of numbers. And keep your cursor on the number which is the answer, because that's as you jump onto it, you see it gets big here, and it's easier to make sure you don't make a mistake and not to get mixed up with all these numbers up here. So the next is 256, the next one is 1024, 4096. I think that's the end of it then. Okay, and you have 4 squared, 4 cubed, 4 to the 4, 4 to the 5, and 4 to the 6. So you can see it's very much using technology, but of course now we're using technology that you're allowed to bring into the exam. So changing it to 9, hitting AC, del 9, and you have 9 to the x. And I'm going to run that from a start of 1 to an end of 6 and a step of 1. Again, we're getting all our numbers, and I'm writing them down at the bottom here: 9, 81, 729, 6561, 59049. Oh my god, what's happening now? 531441. Hopefully that's the end of it. Okay, and you've 9 squared, 9 cubed, 9 to the 4. Yes, we can use our calculator to get these, but you certainly don't want to be thinking about, well, will I learn them off? You definitely don't want to be learning those ones off, because there's absolutely no need. And you can see now on your computer, on your calculator at least, how you can calculate them really quickly. So we're going to leave this as our so-called table. Okay, and then we're going to answer this bit here. Using the table above, find a value for x and a value for y in which each of the following equations for y. In each of the following equations, 2 to the x equals 4 to the y. Well, first of all, there's a lot of, or is there a lot? Is there a power of 2 that's equal a power of 4? Well, there's 16. So you have 2 to the 4 equals 4 squared. Now that will not normally work, but it works there. And then they're saying 9 to the x equals 3 to the y. So something in the line of 3's equals something in the line of y's. Well, of course, 81 is in both. So we go 3 to the 4 equals 9 squared. And of course it is, because 9 is a square of that. And they're getting at something which we'll be studying in more detail later on. Now we're on to what's actually your homework. And it's question 5. And after we get over the fact that it's a bit frustrating or annoying, maybe that they didn't explain certain things to you in the book, or that there's sort of a choice in how you think about how you're going to give your answer, we'll get over that, and and I'll try and explain to you what your different options are for presenting it. So it says to use the rule, the product rule. The product of two powers with a common base, very important to have a common base A, is equal to a single power with their sum. Okay? So let's go 5 cubed times 5 squared is 5 to the 5. Because you add up 5, 3 and 2, done. 8 to the 7 times 8 cubed equals 8 to the 10, finished. 6 is really, it's understood, okay, it doesn't say it, but it's really 6 to the 1 times 6 squared equals 6 cubed. Minus 5 cubed, I'm just going to take out the minus because I can call that 5 cubed times minus, and a minus by minus is plus, so there's two odd powers. Okay, let's leave it in for a second. It's minus 5 to the 10, but anything to an even power you can drop the sign, so that's 5 to the 10. That's the answer, 5 to the 10. Okay, now we've minus 2 to the power of 6 times minus 2 to the power of 3. So first things first, add the 6 and the 3, you get minus 2 to the power of 9. Now the minus, an odd to a negative to an odd power is just the minus can be pulled apart away from the index. So you have minus 2 to the 9. And we're coming down now to this half, which we're going to have to deal with. You have a half to the 7 times a half to the 5. Well, first and foremost, it's half to the 12. But you could also then say that's 1 to the 12 over 2 to the 12, or it's 1 over 2 to the 12. Now it really depends. They said write the following in index notation, but writing 1/2 to the power of 12 would not be considered to be reduced. Because they say, well, why didn't you reduce it to something much simpler and say it's 1 over 2 to the 12? So this generally will not be accepted as the simplest expression, and you'll be, in any exam, you'll be expected to bring it along as far as this. Okay, now we push on. So we have a quarter to the 6 times a quarter to the 5. No, just put it on log tables. Yeah. There's no harm in having the page open and on the logs. So we'd say we haven't a clue where to find the logs. So we go to our indices here, and it's opposite page 21. Okay, and we're scooting down along here, and all we're doing here is we're just saying a quarter is a number just like any other number. So we're using the very top one, the product at the very top left hand of the page, this one up here. Okay, so that means it's a quarter to the 11. And again, based on what I said a minute ago, that really should be reduced to this. And then some people are going to call it 4 to the minus 11. And that's where you start tearing your hair out. You're going, do I have to write a quarter to the power of 11?